Alright, today's lesson is the first lesson. Just ignore the date. I made this slideshow a couple years ago. It's on weighted graphs. Today's lesson objective, I can use graphs and the definitions of circuits and paths to determine the best solution to certain situations. I can use assigned values or weights on edges to determine the most efficient path. That's kind of the key right there, finding an efficient path. So let's review the vocabulary, which is up on your word wall. Euler Circuit is a graph where it's possible to start a node on one node, travel every edge exactly once, and return to the original node. An Euler Path is a graph where it is possible to start at a node, travel every edge exactly once, but end on a different node. The degree of a node is defined as the number of edges that enter the node, including edges that enter, start, and end at the same node. Okay? Alright? Enter should be start and end in parentheses. Alright, so continue. An Euler circuit and path can be determined by the degrees of the graph. An Euler circuit has only even number degrees for every node in the graph, and an Euler path has two odd number degrees, and the rest are even number degrees. Okay? Those are all up on the board here. I will post this in the classroom in Schoology so you have these definitions. Alright. Weighing a graph. Weight. Weight is a number or value that is associated with an edge in a graph. And weighted graph is a graph in which edges have assigned values to them. Okay, so we see this example of a graph here. A and B has a value of 1, B and E has a value of 2, E and D 1, D and C 1, A and C 3, A to D is 4, and B to D is 3. Now, why would that make sense? Okay, now let's explain this. Let's say this is different cities or different towns, and these are roads between the towns, and those are the miles between them. So that's a practical application. Okay. Maybe it's electrical series. Okay, and these are the ohms applied to each one of these different wires. Okay, going to the different junction boxes. Make sense? Or switches, whatever you want to call it. Okay? Now, in a weighted graph, it's not so important to know the node's degree. It is if you're trying to find an efficient thing or an efficient system, which you're trying to do, so you will need to know the degree. So you can see the degree of everything. Don't confuse the degree of a vertex with the weight of an edge. You see how the different numbers are assigned to the things. This E has a degree of 2. Well, so does the value between, the weighted value between B and E. But don't confuse those two, they mean two different things. Alright? Sorry, my mask keeps falling off. Snowplow problem. Now, we've done this a couple times. Now, I want you to understand something. If you look at this, this is one of the questions, or a very similar question to the ones on the assignment. Okay? As a new snowplow operator, you have to decide the best route through the cities you work. In each city, you need to plow all the roads and return to the starting place, but you must also keep from backtracking as much as possible. Alright, so the most efficient route would be the one that touches every edge exactly once. So let's think, what did we learn in the last lesson in Euler circuits and paths? There are two ways to touch every edge exactly once, either through an Euler path or an Euler circuit. An Euler circuit is most efficient because you go back to where you started. An Euler path is efficient, but not as efficient as an Euler circuit because you still have to backtrack. Alright, so let's think about this for a second. These are roads, and this is the time it takes to plow those roads. And since you guys aren't familiar with snow as much as I am, growing up in the Midwest, think of this as a street sweeping problem, okay? So you got to street sweep all the streets, and you don't want to do them more than once, right? So, where would you start to start this thing? First of all, let's determine what are the degree of each vertex? What's the degree of B? Or A, B, C, D, and E? What are they? A is what? 3? Alberto, is that what you said? What about B? C? D? And then E. So what do we have? We have how many odd and how many even? Does it fit any of the definitions of Euler path or Euler circuit? at your definitions up here. It says, an Euler path exists when two vertices are of an odd degree and the remainder of an even degree. Do we have two vertices that are in an odd degree? Aren't A and E odd? Are the rest of them even? 2, 4, and 2? Yes, so we know an Euler path exists. And an Euler path exists in this path, in this particular graph, if you start at one of the odds and end at the other. You should touch every graph exactly once, okay? So check it out. A, B, C, D, E, A, C, E. Test every path exactly once. But we got to get back to A. So how do we do that in the most efficient manner? This is where it takes some thought. Normally you say the fastest distance between 2 points is a straight line. This is just a graphical representation. The value is given right here. Is that the least amount of hours to get from C to A? Or is there another path you can take that's less hours? What did you say, Noah?
No.
There is no path? Think of the sum of the values it takes to get from C to A on any other pathway. Is there another pathway that's less than 7? E to C to A, is that what you said? E to A is 7. What about E to C to A? That's 6. That's less, isn't it? So any pathway between A and E, as long as when you go from A to E or E to A, whichever direction you go through C because it's less than going directly to A or directly to E. Does that make sense? Efficiency is important, especially when you're talking about something like this. Or, say we're talking about cable connections. Internet. You got so much resistance, you got so much distance between 2 points, your cable connection stinks. The shorter the distance, the better the connection, right? Really important. Here we go. Alright. This explains exactly what I said. We see that vertex A and vertex C are both degree 3. B and D are both degree 2, and vertex C is degree 4. With two odd degree vertices and remaining are even, this falls into the definition of Euler path. We start at either odd degree vertex and find a path that crosses every edge only once, and then at the other odd degree vertex. Which odd degree vertex does not matter. This is one example. Then to return, we take the least weighted path. AE has a value of 7, but ECCA has a sum value of 6, so that is the most efficient return route. You see where I got that from. Alright, that's actually it for the entire lesson. True story. Okay, you go to the RenFest, you can use what you learned to find the most efficient path to all the cheap booths you wish to visit, saving you money, time, and worn out legs. Alright? So, any questions about that? It's pretty simple. Weight is simply just a value we assign to the edge. Degree is the value we assign to the vertex based on the number of edges that go in. So do not confuse those two, okay?